In the last video, I talked about counterfeit parts and how common they are. And I was talking about a unit that I repaired several years ago for a fella. It was a Technics SA5470. And I was doing burn-in on these parts because I thought they looked questionable, and it blew up. And I never published the findings. And I found the files. We're going to take a look at that now. I'm back on the Technics SA5470. Output transistors, drivers, and bias resistors that were missing are here. Let's replace them and get this unit working. Since I already did this video before, the repair on this one was done. We're not going to show you the repair. We're going to go over the transistors, look at the transistors, and so forth, and then we'll jump ahead to the load testing where it went boom. I'll play you my new track as background here as I get into this, because there's not going to be any talking on this video until we get into the testing stage.
Sitting on the porch, watching the world go by, with a whiskey in my hand and the stars in the sky. Thoughts of you race through my mind like a dream. But some things in life ain't always what they seem. You said you'd always stand by my side, but love is a road that gets tough to ride. You keep asking why I can't.
These transistors will have insulation hardware on them.
That you won't understand till you walk.
Let's get the original. So let's get a look at the new ones. Make sure that they are the same. I don't know whether these are real or fakes. They could very well be fakes. I mean, they look real, but they're not made out of the same metal. If you look at the original ones are shiny, and these other ones the new ones are dull. So they may very well be fakes. Okay, if we look closely at these transistors, this is the original one. This is the replacement. I get a real sneaking suspicion that this is probably a fake. Right? It's a completely different type of metal. Certainly not an original, that's for sure. It's not an old stock. This is most likely this is a fake. But I guess we'll find out soon enough. If it goes kaboom, then it'll be my fault. I'm pretty sure this is not an original NEC transistor. This is the problem with when you buy anything off eBay. This is one of the reasons I don't buy parts off eBay. I never buy parts off eBay. And this is the reason why, is because these counterfeiters have done a very good job. These came from China. You see the original one's got a dot on here. This one doesn't, but if you look at the lettering, like even the font, look at the N and the E. They're not quite the same, right? The font is not quite the same. They got pretty close on the N, but the E definitely, and even the C is the font is not the same. It's a wider here. That's a trademark. So the lettering is different. The A, look at the bridge here on the A is lower than on this one. You see? Yeah, I'm pretty sure this is a fake. This is the original one. The font is just different. On to this one, I have the two driver transistors down here that need to be changed. I've got replacements for them here. Anybody that serviced Sony televisions or Sony Hi-Fi VCRs probably recognize this part. It even says Sony on it, but it didn't come from Sony. When these parts were purchased from Sony, they were around $85 for this module. and we were buying them from Main Electronics for around $9. This, of course, is the MTS stereo IC SBX 1637A. These actually worked, but they were counterfeit. They were counterfeit parts. And they worked for a while. The problem with these is that they didn't process the stereo signal properly. And they would work, but they didn't sound like an original. And SAP, when someone used the SAP audio for descriptive videos, they didn't have the DBX decoding on them, so everything sounded compressed and it just sounded awful if you put an SAP channel on with one of these. And if you put the original Sony module in from Sony that looked identical, had the same part number and everything on it, it sounded fine. So that's another part that we discovered was defective. So it was written off, and well, when it was thrown in the garbage, it just followed me home. I figured if I ever had a TV that I needed a module for, I had one. Of course, it's never been used. It's been sitting here since, well, probably 2000. So it's been sitting here for 22 years. It probably doesn't work now, but visually you look at it and it looks original, but they're not. Okay, once again, we'll turn it on. Speakers are turned off at this point. Okay, now we should have sound if I turn on the speakers. I don't hear anything on the right channel. Left channel's working. Controls are dirty as all hell. The switches are dirty too, it sounds like. So, I guess the first thing now, or the next thing we got to do on this is we got to clean the controls, because the controls all sound like absolute crap, because this thing's probably been sitting in a barn somewhere for the past 40 years. Okay, I'm going to do a little hack here. I'm going to put this is a 12 volt fuse bulb that burned out. Good thing I didn't buy that $20 pack of bulbs, because they're 8 volt rated and these are 12. So you can imagine how long bulbs rated for 8 volts would last on 12 volts. They'd be nice and bright, but they would not last very long, believe me. So I'm going to use a 12 volt. This is a little 3 LED chip setup. I'm going to solder it on to the fuse bulb end, and then we can just snap it back in place. So that looks good to me. Nice even lighting. Let's throw this one back together. I ran the unit for a while, just at normal low listing levels, but because I knew the guy that had this was intending to sell it, I wanted to put it under a load test. So we put some load resistors on and we'll crank it up and see what happens. So today I'm going to load up the SA50, what is it, the 5470, 65 watt amp. This is the one that we put the new transistors in there the other day. I've been running it for the past, what is it today? Today's Tuesday. I've been running this. I repaired this on, was it Thursday? So I ran it Thursday night, I ran it Friday, I ran it Saturday, I ran it Sunday. I didn't run it last night because I was just busy with other things. I want to load this up before I return it to the customer, because I'm not convinced that the replacement transistors that we put in are genuine. And the quickest way to find counterfeit transistors is to load it up. I don't want to send it out and have it come back because it fails. So this is what I'm going to do. I've got some 50 watt 8 ohm resistors. I'm going to put the 50 watt resistors on the output channel. I'm actually only going to drive the one channel. It's the left channel, so I don't need to worry about the right channel. So I'm not going to put any undue stress on the right. I'm going to connect both of them up, but I'm going to run it with the balance control set to the left. And I think I'll probably put a tone in. We'll do something like a 100 hertz tone or something. I'll look at the waveform on the scope, make sure everything's clean, and I'm going to run this thing up. I'm not going to take it to the point of clipping. That's the point. I'll watch it on the scope, and if I get anywhere near clipping, I'm going to back it down. And we'll run it, load it up to maybe 70% power, and let it run for a while. If this thing can cook, and these resistors are going to get hot as a firecracker, they're going to get real warm. So, but I'm going to let it run for a little while, and if it holds out and doesn't fail, then we're good. We're good. So let's hook it up. I'll get my tone generator on there. We'll get a tone going and see what happens. This is the setup I'm using. I'm suspending. I'm only going to put power to one channel, first of all. So the other one I can leave on the bench because I'm not going to get it hot anyway. But this resistor is going to get smoking hot, so I don't want to damage my probe. So I've just got a jumper clipped on, and I've just got it suspended in air so that it's not going to sit on anything that it could damage, because this resistor is going to get quite warm. I've got the scope connected to it now. I've got the speaker still connected, but I will be shutting the speaker off. I haven't put the tone generator on yet, but we've got the speaker going, and if I turn up the volume. So now I'm going to hook up my tone generator so I can run tone, and I'll turn the speaker off as I crank this thing up. As I say, I'm not going to take it to full power, but I'm going to take it relatively, I'm going to say close, at least 50%. This is a 65 watt per channel amplifier, so I don't think I'll be driving more than about 30 watts. Because 30 watts is going to be bloody loud, right? 30 watts will blow the speaker that I'm running it on because it's just a small speaker. So that's why I'm going to just do it through the load. So let me get my tone generator connected, and we're going to feed a tone and observe what happens, and hopefully everything's going to be good. Although I'm not holding my breath because, again, I've had very bad luck with counterfeit transistors in general over the years, and I'm pretty certain that the ones that I got are not genuine. My generator is on. I've got 100 hertz tone going here. I'm going to get a shot of the scope and turn off the speaker, obviously, because otherwise I'm going to blow my speaker. So speaker's off. I'll start to increase this. We'll bring the gain down on the scope. We'll see what happens when I get it. Okay, so there, that was maximum power. You can see the amp is starting to clip, so we're going to run it right about there. There's clipping. We're going to run it right there. That's 20 volts per division that we are, because I'm on a times 10 probe. So 20, 40, about 60 volts is my peak to peak. It's a nice clean signal. There's no distortion. As you can see, that signal is about as clean as it's ever going to be. The resistor is getting warm. It's getting quite warm already. Yeah, okay. Let's let it cook and see if it'll continue. I'll leave the camera running just so you guys can see, so that if something happens, then we'll witness it. We'll see how long it'll run. And I'll let this thing run. If this thing can run for 10 minutes without blowing up, then without my resistor burning up too, I'm just testing the temperature of the resistor, and it is getting toasty warm. But I guess time will tell whether this is going to work. And this is what's referred to as burning an amp in. You're basically running it at maximum power just to make sure nothing is going to fail. Looking good. So that's there. So you can see where it flattens out. So we don't want to run it into clipping. So this is about the maximum output that you'd ever get. And this should run all day. At that power, at this level, there's no clipping, there's no distortion. That signal is absolutely perfect. This should run all day. You should be able to pound this thing for hours, and this shouldn't blow up. This being a sine wave test, this is kind of the acid test. I'm just putting my hand over top of the unit now, and I can feel the heat sink. I can feel heat starting to rise off the heat sink. So I can feel heat now. A little bit of heat. Ah, oh, geez, that's hot. That's hot as hell. Holy crap, that's hot. What happened? I just heard the relay click. It's gone into protection. Power's still on. The lights are still on. But I got no output. It's not a lot of heat. I feel a little bit of heat. That's hot. that's really hot. Okay, something's gone wrong with this unit. I'm going to unplug it. And I guess we're going to pull it apart and see if the replacement transistors failed. I bet they did. I bet you these were fakes and they just didn't hold up. So, and if they failed, there could be other damage that's occurred now too. But hey, it's better. It's better it blew up here. I was kind of suspecting that that was going to happen. I'm not surprised that it failed, because even when I was doing the video initially, I had voiced some concern about the transistors themselves. And this is exactly why, because I've seen this happen so many times in the past. So let's get the top off this thing and see what went wrong with it. I bet you the resistors burned up again too. I bet you I burned up the resistors. Okay, meter. Let's get some light over here so I can see what I'm doing. Okay, we'll check the transistors first and see whether the transistors have popped. So transistor test. Oh. Oh, that one's not, well, it's not shorted that way. How about here? Okay, that transistor, well, it's not, yeah, it's not, that one's not shorted. Uh-oh, it's shorted that way. That one's shot, that's one of the new ones. How about this one? That one's shorted. So both those outputs failed again. How's my resistors look that I put in? Okay, that one's gone open. It burned that resistor open. That's supposed to be like 0.47 ohms. This one here, what is it measuring? 1.6. Well, my probes have a 1, so that's right. That one, so that one's not open. That one's gone open. These two transistors have failed. I wonder if the drivers also went bad. Let's just check the drivers and see if the drivers are popped. Emitter to collector is, whoops, put the meter in. Emitter to collector is, oh, that's the collector. So that one doesn't look like it's popped. Let's just see, did it pop or not? That one's measuring okay. That transistor's good. That one didn't blow. Okay. What about this one? Did this one blow? That one blew. That's interesting. So this transistor popped. This one's still okay. That one's good, right? Let's see. No, actually, no, it's got leakage too. I'm getting across emitter to collector junction and emitter to base. It might be something else causing that though, but I would say that it's probably shot too. So both transistors as well as the resistors are gone. It looks like a couple more resistors may have burned in here that weren't burned before, because I checked those before. That looks to be a bit burnt, as does this one here. So yeah, that's what happens when you put in counterfeit parts. That's what I was afraid was going to happen. I'm surprised that it actually lasted as long as it did, because usually when you get counterfeit parts, they go immediately, like as soon as you power them up and put any type of power to it. The fact that this thing ran for 4 days at average listing level. I wasn't pounding it because I don't want my neighbors complaining about the noise. So unfortunately, this one is gone. Whether the guy that owns it is able to source other transistors, I mean, if he wants to try again and get some more, I'll certainly be happy to put them in. But I fear that the same thing is going to happen again, because now we've got 2 more resistors to change on it as well, but those are cheap parts. I have a feeling that we're going to have the same problem. That's the problem with vintage parts, is that there's so many counterfeit parts out there. I was running into counterfeit parts when I was working in the business. I can tell you the name of the shop I work for. I work for a shop called Jack's Radio and TV out here in my neck of the woods. And I was the service manager, head service tech there for 20 years. The shop closed up. I left in 2003. The shop closed up 2012. Out of respect for the owner, I never mentioned the shop that I work for. He passed away, so I feel I can probably say the name of the shop now that I work for. But we were a large self-servicing Sony dealer that was one of the largest independent sales or independent stores certainly in the province. We sold a huge amount of product and serviced a lot of product. And at one point, I had 4 guys working under me. There was 5 of us working in the shop in the heyday of the 80s. So we did a lot of this stuff and started seeing a lot of counterfeit parts showing up. We were buying them from Main Electronics. I can say the name of that shop too because the shop is long gone and the owner has passed away, so I don't have to worry about mentioning that name because it no longer exists. But we used to buy our parts from Red Electronics and Main Electronics, and we started seeing counterfeits showing up in the field. I would say probably early to mid 90s. We started seeing a lot of counterfeit parts to the point where I wouldn't use anything. If I was using a part, it either had to come from the manufacturer or it had to be ECG. Here's one last look at the replacement part versus the original. You can see the differences right there. I mean, even the top, like this is not as deep as the other one. You can see, if you look at the depth of the actual top case, this one here is taller by a little bit taller than this one. But this looks like it's been sandblasted. And when we used to get parts from ECG was Philips, and a lot of them were taken over by NTE. Like the brand was taken over by NTE, which is a replacement company. But Philips used to own the ECG line. And Philips would a lot of times use their own semis and have them make their own semis to the same specs as others. But other times they would buy factory semis from companies like NEC or Sanyo or Toshiba, and they would label them with their own. And when they bought original semis from the manufacturer, you notice there's a dot here, a black dot. There's not one on these. When they bought the original transistors, ICs, etc. from the manufacturer, they sandblasted them so that they get off all of the original number, right? You can't just take the paint off because you'll always be able to see it the way that they're stamped. So they would sandblast the parts and then print their own ECG catalog number on. And they were original parts that they would put their own numbering on. And they all came out looking like this. The ones that were shiny, the only ones I think that they had were shiny, were the ones that Philips made themselves. And they put their own number on. But when they sourced other brands of parts, they all looked like this because they would sandblast the original coating off to renumber them. So I get a sneaking suspicion that's what's happened on this. This is not a 2SD388A. This is some other brand of transistor. I mean, I don't think probably not even NEC. It could be anything, but it's some other transistor that had similar but not identical specifications to the original, and they just stamped the number on it and sold it like it's an original. It was running rampant, and we went through hundreds of them. When I was in the business, I went through hundreds of these problems. So anyway, unfortunately this one here blew up, but you know what? It's better that it failed here than failed when it was back at the customer's house, or worse, because the fellow that owns this, he sells a lot of used equipment on, I think he sells most of his stuff on Facebook, but it's a lot better that it failed here than if he had sold it to somebody and the first time they cranked it up it blew, because then he would have someone angry at him. So I guess it worked out for the best. Again, if he wants to try again, and he wants to get some more, we'll try it again, but I think that we'll be in the same boat. We're going to end up with another set of fakes that are going to go and end up exactly the same as these ones as soon as it's cranked up. And that's why a lot of times I kind of try to shy away and tell people when they've got power amps that have got failed transistors like this, that they might be better to walk away, because with the prevalence of counterfeit parts, this is the situation you run into time and time again. Anyway, thanks for watching. We'll catch you in the next one. Bye.